Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board from the subject physics. Okay. In previous lecture, we have learned about the second method for the calculus, that is the integration. Which are the rules of the integration, or why we have to apply the method of integration, and which are the two different types of the integration, in which we have learned about the definite integration and second one is the indefinite integration. Now in today's lecture we have to learn about the kinematic equations of motion with the help of the method of integration. Okay, we have to prove the kinematic equations of the motion or the linear motion with the help of the method of integration. Okay, as we know which are the three equations of a kinematic motion, that is the first one is the v is equal to u plus at, then second one is the s is equal to ut plus 1 half at square, and the third one is the twice as is equal to v square minus u square. Okay, so we have to prove all these three equations based on the method of integration. Okay, and for that purpose we have to go for again the same methods of the integration. We have to apply the rules of the definite integration here, that is we have to use some limits to our expressions. Okay, so for the first equation, that is v is equal to u plus at, let us consider that we have the motion from time t is equal to 0 to time t is equal to t, and during that motion the velocity changes from u to v. Okay, so let us consider the equations, the kinematic equations. Okay, kinematic equations. So in that the first is v is equal to u plus at. Then for this let us consider that let the body is in motion and at t is equal to 0, v is equal to u, at t is equal to t, v is equal to v. That is, it is the final velocity and this is the initial velocity. Okay, this is the initial velocity. Now let us draw this, that here time t is equal to 0, then v is equal to u, and here when t is equal to t, then v is equal to v. Okay, this is the final velocity, this is the initial velocity. Okay, now we have the equation of the acceleration as a is equal to dv by dt, because how we can get the acceleration from the graph of vt curve. For that purpose we have to take slope of that vt curve, and slope gives us the formula that a is equal to dv by dt. Okay, acceleration is nothing but the change in the velocity with respect to time, and in the graph also we have seen that the slope of that graph gives us the value of the acceleration, and a is equal to dv by dt. Okay, we know a is equal to dv by dt, therefore a into dt is equal to dv. Okay, a into dt is equal to dv. Now we have to put the limit to this equation where a is not the variable. Okay, here we have to write it, here a is not variable. Okay, now we have to put the limits to this equation so that it becomes a integration dt is equal to integration dv. Now what will be the limits for this equation? Which are the limits we can apply? We see t changes from 0 to t and v changes from u to v. So write the lower limits to the lower side and the upper limits to the upper side. Okay, we have to write down 0 to t. Then the upper limit for this, it is u to v. Okay, it will be u to v. Then we can take the integration of this term as a. Integration of dt is t. T is from 0 to t is equal to, what is the integration here? Here v into u to v. Okay, now we have taken the integration and also we have written there the limits. Now we have to apply the limits. Okay, so we that get a t minus 0 is equal to v minus u. Okay, so that we will get at a into t is equal to v minus u, or we can write it as v is equal to u plus at. Okay, we can write this as v is equal to u plus at. Okay, just we have to apply the limits as per our the condition, that is at time t is equal to 0 our initial velocity v is equal to u, and at time t is equal to t our initial velocity, our final velocity v is equal to v. Just we have to put these limits in this equation. Then when we take the integration of this term by the formula x is equal x raised to n is equal to x raised to n plus 1 upon n plus 1. Okay, by using that formula we will get the equation as, here there is no any term t, so t raised to 1 plus 0 upon 1 plus 0 will get the equation, or for your convenience I will write here 1 upon 1. Okay, so you will get the equations as t upon 1 0 to t, v upon 1 u to v. So you will get here the value a is equal to, when we apply here limits t minus 0, and in this when we apply the limits v minus u, we will get that at is equal to v minus u. Okay, so we will get v is equal to u plus at. We will get the first equation of the kinematic motion for the linear motion, that is the v is equal to u plus at. Now we have to move towards the second equation. Okay, so for the second equation also we have to consider some conditions here. Okay, we have to consider some conditions here. And which are those conditions? We have to go for some conditions here. If we consider the second equation, that is second equation is s is equal to u plus ut plus 1/2 at square. Okay, ut plus 1/2 at square. So for this again we have to go for some consideration, that let the body is moving with uniform velocity. Okay, let the body is moving with the uniform velocity, and during that uniform velocity the body is covering some distance. Okay, so the body is covering some distance from this to this point. Then when t is equal to 0, this to the t is equal to t, it will cover some distance s here. Okay, it will cover some distance s here. So at t is equal to 0, s is equal to 0, and t is equal to t, our displacement s is equal to s. Okay, our displacement s is equal to s. Now as we know, our body is moving with the uniform velocity. Anywhere you can take the value of u, it will be equal to u. Okay, so as it is moving with the uniform velocity, u equal to u, and here u equal to u. Okay, we don't have to go for the change in the quantity because u is not the variable here. Okay, u is not the variable. Now we have the equation of the velocity, that is it is a change in displacement upon time. Okay, we have the equation of the velocity, that is the change in displacement upon time. So we can write here, we know velocity is equal to ds upon dt. Okay, velocity is equal to ds upon dt. So we can write it as v dt is equal to ds. Okay, we can write it as v dt is equal to ds. Okay, now if we apply the limits, then what will be the limits for this equation? What will be the limits here? Okay, here the velocity is not changing. Here velocity is uniform. Okay, that is v is not variable. Okay, v is not the variable. So here in this case, whenever we have to apply the limits, we have to apply the limits to the s and the t. Okay, so after applying the limits, after applying the integration with limits, we get v integration dt is equal to integration ds. Now what is the limit here? For the t it is 0 to t. Okay, which are the limits? It are 0 to t is equal to integration. What is the limit here? What is the limit here? That is 0 to s. Okay, it is 0 to s. Integration 0 to s ds is equal to integration 0 to s into u plus at into dt. Okay, so if we take the integration of all this term, we will get integration 0 to s ds is equal to integration 0 to s u dt plus integration 0 to s at into dt. Okay, we will get integration at into dt. So that if we consider the integration here, the rules of the integration, we will get the value as s minus 0 is equal to u into t 0 to s, then I will repeat here 0 to s plus a into t square upon 2 0 to t, here t. Okay, so what is the integration of s to 0? The s minus 0 will get u into bracket t minus 0 plus a into bracket a by 2 t square minus 0. Okay, we can write down s is equal to u t plus 1 half a t square. Okay, we can write down s is equal to ut plus 1 half a t square. Okay, this is the second equation of kinematics for our linear motion. Okay, we have the second equation of kinematic for this linear motion, that s is equal to ut plus 1 half a t square. So what we have to do to start this equation is just we have to consider one condition, that the body is moving with the uniform velocity. Okay, and what is the equation of the velocity? Accordingly we have to take some change in the conditions, that v is equal to ds by dt. At t is equal to 0, the displacement s is equal to 0. At t is equal to 2, the displacement s is equal to s. Now here u will be constant anywhere, so acceleration will be a constant. Acceleration will also be a constant. Okay, then we have the limits of the time and the displacement. When we have the value of v from the first equation, that is v is equal to u plus at, then we have to put down this in the equation 0 to s ds is equal to 0 to t here. Okay, it is 0 to t u plus at dt. Okay, then here 0 to t, then 0 to s 0 to t u dt plus 0 to t at dt. Then s will take the integration of ds, it is equal to s. Okay, then s applying the limit 0 to s, then u into integration of dt, that is the t 0 to t plus a integration of t, it is t raised to n plus 1 upon n plus 1, it is t square upon 2, applying the limit 0 to t, then we will get s minus 0 is equal to u into t plus a by 2 into t square minus 0. Okay, then we'll get the equation as s is equal to ut plus 1 half at by 1 half a into this t square. Okay, this is the second equation of kinematics by using the integration method. Now we have to go for the third equation of the kinematics, that is the, what is the third equation? What is the third equation? It is v square minus u square is equal to twice as. Okay, we have the third equation that u square minus v square is equal to twice as. If I write down here that third equation is the twice as is equal to v square minus u square. Okay, then let us consider that let body is moving with some velocity u at t is equal to 0. Okay, so if we draw the diagram, we come to know that at t is equal to 0, u is equal to v is equal to u, and at t is equal to t, then v is equal to v. Also s is equal to 0 here, and s is equal to s. Okay, during that interval the body is traveling for the time period t, and during that interval it is covering a distance equal to s. Okay, so we have the equation of the acceleration. We know a is equal to dv by dt. Okay, we know a is equal to dv by dt, so let us multiply this right hand side with the ds. Okay, so we'll get multiply and divide by ds to RHS. Okay, we will get a is equal to dv by ds into ds by dt. Okay, we know what is the ds by dt. What is the ds by dt? ds by dt is nothing but the velocity, so that we will get dv by ds into v. Okay, we will get dv by ds into v. So here we can write down it as a ds is equal to v dv. Okay, we can write it down as a into this ds into v dv. Here a is not a variable. Okay, a is not the variable here, and we have to apply the limits to this equation. Okay, so what will be the limits to this equation? What is the limit for the s? S is from 0 to s, and for the velocity v it is u to v. So let us apply the limits. Applying limits, we get a integration 0 to s ds is equal to integration u to v v dv. Okay, integration u to v v dv. Then when we apply the limits, we will get s into bracket s a into bracket 0 to s into what is integration of v square by 2, okay, into bracket u into v, so that we will get here a into bracket s, okay, s minus 0 is equal to v square by 2 minus u square by 2. Okay, so that we will get here a s is equal to 1 upon 2 v square minus u square, or we can write it down as twice as is equal to v square minus u square. Okay, we can write it down as twice as is equal to v square minus u square. Okay, and this is the third equation for the kinematics for the linear motion. Okay, this is the third equation of kinematics for the linear motion. How to go for the proof of this equation? Just we have to start that let a body is moving with initial velocity u, and it is covering a distance of s during the time interval t. Okay, just we have to consider the equation of the acceleration, that a is equal to dv by dt. Then we have to multiply and divide that by the ds. Okay, we multiply and divide to RHS. Okay, then we'll get dv by ds is equal to ds by dt. And what is the ds by dt? What is the ds by dt? Then this ds by dt is the velocity v. Okay, ds by dt is equal to velocity v. Then we just have to multiply this a by this term in the denominator. Then we'll get a into ds is equal to v dv. And how we can apply the limits here? For applying the limits, we have to consider which values are the variable. As the acceleration is not the variable here, just we have to consider that a is equal to integration 0 to s ds, and the limits we have to apply for the velocity is integration u to v for the term v dv. Okay, now we have to take the integration of this term. Integration of ds is the s, then its integration is 0 to s. Then for the RHS, it is v square by 2 u to v. Okay, we get a into bracket s minus 0 is equal to v square by 2 minus u square by 2. Okay, as is equal to 1/2 v square minus u square is equal to, if we take this 2 here, then our equation becomes twice as is equal to v square minus u square. Okay, so by using the method of a calculus, that is the second method of the calculus, that is the integration, we can prove the kinematic equations of the linear motion. First of all, we have seen the first equation, that is v is equal to u plus at. Then depending on that term, we have to go for the second equation, that is s is equal to ut plus 1/2 at square. And in the third equation, we have to go for some considerations. We have to just multiply and divide the term of the acceleration, that is a is equal to dv by dt. Then we'll get the one physical quantity there, and integrating that physical quantity, we can get the third equation of the kinematic motion, that is the twice as is equal to v square minus u square. Okay, now we have to go for one short problem, that is, it is nothing but the, you can say, one expression for the displacement of the nth second. Okay, whenever the body is in motion, what will be its motion during the n minus 1th second? Okay, what will be its motion during the nth second? Nth means what? If you are in a going from 10 to 11th, then what you are saying, that you are currently in the 10th. Okay, you are currently in the 10th. Or whenever you are going to the 11th to the 12th, then what you can say, that you are currently in the 11th. Okay, you are currently in the 11th. So if we draw the graph of your study, then you can come to know that you are, this is the 11, 10, 11, 12. Okay, this is the 10, 11, 12. When we have to find out the displacement of the nth term, then in that case you can say that you are currently in the 11th. You are currently in the 11th means what? This is the 10, this is the 11, this is the 12. So you are currently in the 11th and you have not completed your 12th, means you have to go for this consideration. Okay, you are during this consideration, you are not in the 12th, but you are approaching to the 12th. Okay, you are approaching to the 12th means you have to consider this 11th condition. Okay, you have to consider this 11th condition. Similarly, we have to find out the displacement for the nth second. Nth means what? Suppose this is the last second. Suppose this is the last second. Then you are in the nth second. Okay, then here is the n, and this will be n minus 1. Then what will be the nth second? What will be the nth second? That this n minus 1 will be your, once you are currently in the 59th second, you are currently in the 59th second, so that's why you have to consider nth second there. Okay, displacement of the nth second you can calculate. Okay, so for that purpose we have to go for one considerations here, displacement of the nth second. Displacement of nth second. Okay, so if we draw one diagram here, initially you are at t is equal to 0 and your velocity is u, okay, and your displacement s is equal to 0. Now you have completed the time t is equal to n and s is equal to sn. Okay, now at the time period of t is equal to n minus 1, your displacement will be s is equal to s suffix n minus 1. Okay, your condition will be s suffix n minus 1. So here we have to take the limits for this last session. Okay, we have to take the limits for this last second. In that, what will be the upper limit? What will be the upper limit? The upper limit will be the Sn and the lower limit will be S minus 1. Okay, so this is the duration for which we have to go for finding the displacement. How much will be the displacement during this duration? Okay, and for that the time period will be t is equal to n, so t is equal to n minus 1. Okay, the time seconds we are considering the n seconds. Okay, total it is given nth second, so we have completed the t is equal to n and n minus 1, and during this period how much will be your displacement? That will be your displacement for the nth second. Okay, so we know the quantity of the velocity, that is v is equal to ds by dt. Okay, so we know v is equal to ds by dt. Okay, we know v is equal to ds by dt. Then we can write it here as v into dt is equal to ds. Okay, or we can write it as ds is equal to u plus at into dt. Okay, we can write it down as ds is equal to u plus at into dt. Okay, so we can write it out u dt plus a in at into dt. Okay, now by taking the limits, okay, now taking the limits, taking the integration and limits, integration with limits, we get integration from s to n minus 1 to s of n of ds is equal to u integration t is equal to n minus 1 to n of dt plus what is here a into integration of t dt n minus 1 into n. Okay, so that we will get the integration here, integration of s n minus 1, okay, s n minus 1 s n is equal to u into t n minus 1 to the n, okay, plus a upon 2, that is t square upon n minus 1 upon n, so that we can write it here s suffix n minus s suffix n minus 1 is equal to u into t. What is the value of t? That is n minus n plus 1. Okay, by taking the limits here we will get n upper limit minus lower limit plus a by 2 upper limit. What is upper limit? N square minus n square, or we can put down here n square plus minus twice n. Okay, you can put here n square minus twice n. What is the square? Plus 1. Okay, so that we can write it here Sn minus s suffix n minus 1, it will be equal to u here n will get cancelled, u into 1 plus a by 2 into bracket, this n square and n square will get cancelled to bracket twice n minus 1. Okay, we will get twice n minus 1. So this is the final equation of our nth second. Okay, this is the displacement of the nth second, that is, or we can write it here as u Sn minus n minus 1, that is the displacement in the nth second, is equal to u plus a by 2 twice n minus 1. Okay, u plus a by 2 twice n minus 1. Okay, so this is the one smaller equation of the displacement at the nth second. Okay, by using the equation or the method of the calculus, we can find out such expressions also.